What You Think You Know Might Be Hurting You by James McGinn. There's a famous saying, "It's not what you don't know that gets you into trouble, it's what you think you know that just ain't so." This idea applies everywhere, but it's especially dangerous when it comes to science. We like to think of science as a process of discovery where every idea gets tested and retested until only the best remain. But the truth is, sometimes assumptions slip through unnoticed and solidify into facts, without ever being properly challenged. And that's when things start to go wrong. Groupthink is a big part of this problem. It's when you take on someone else's assumption as if it were your own, often without even realizing you're doing it. It's sneaky, it works at a subconscious level, so you don't even realize you've been influenced. Want an example? Let's break down a Quora response to the question, what causes tornadoes? Answer by Gabriel Garfield. There are many theories for what causes tornadoes, but they are untested. The Vortex 2 Field Project, which I am a part of, aims to surround tornadoes with various weather instruments to try and understand why they form. We know that the parent thunderstorm causing a tornado, i.e., a supercell, forms due to a combination of buoyancy and wind shear. Something similar likely happens with a tornado, but the exact mechanisms are still unknown. At first glance, this sounds perfectly reasonable, right? Gabriel seems pretty knowledgeable, and the answer is filled with the kind of language we've come to expect from experts. But there's a hidden assumption here, and it's a big one. We know that the parent thunderstorm causing a tornado, a supercell, forms due to a combination of buoyancy and wind shear. But do we really know that? Do we know for sure that thunderstorms are the parents of tornadoes? Is buoyancy actually a factor? And while we're asking questions, do we even know if moist air is more buoyant than dry air? The truth is, we don't know these things. These ideas, just like the theories Gabriel refers to, remain untested. And this problem is far from new in science. Ideally, science is supposed to be about constantly challenging old ideas. Theories should be tested rigorously, and assumptions should never be accepted as fact without proof. But in practice, some assumptions get passed along unchallenged from one generation of scientists to the next, until they become almost sacred. Once that happens, questioning these assumptions can lead to serious pushback from experts who've spent years building their careers on them. These experts can even become gatekeepers of truth, protecting their own ideas and defending the status quo by making their claims sound more complex than they actually are. Take, for instance, this paper from a group of professional meteorologists, Tornadoes in the Central United States and the Clash of Air Masses by David M. Schultz, Yvette P. Richardson, Paul M. Murkowski, and Charles A. Doswell III. The paper advises journalists to avoid the phrase, clash of air masses, when talking about tornadoes, suggesting that the term oversimplifies the real science. But what does the paper itself say about tornado formation? Here's a snippet. Storms occur when warm humid air near the surface is capped by drier air at higher altitudes, with temperature decreasing rapidly with height, originating from higher terrain to the west or southwest. This creates instability, providing energy for storms. Large changes in wind with height, wind shear, over both shallow, lowest 1 kilometer, and deep, lowest 6 kilometers, layers, combined with the instability and high humidity near the surface, create conditions favorable for tornado formation. It sounds impressive, but is this really an explanation? Or is it just a series of observations dressed up in technical language? Let's break it down. Storms occur when warm humid air near the surface is capped by drier air at higher altitudes. Okay, that's what happens, but why? This creates instability, providing energy for storms. Isn't that just restating the obvious? Storms occur when there's instability in the air, that much we knew. But what's actually causing the instability? Large changes in wind with height, wind shear, create conditions favorable for tornado formation. So wind shear is involved, but again, we're still left wondering, why do these changes in wind speed and direction lead to tornadoes? Then the paper goes on to say, Convective storms initiate when air parcels with convective available potential energy, CAPE, reach their level of free convection, LFC, often triggered by ascent linked to air mass boundaries. Here's another example of scientific jargon at work. What do air parcels, convective available potential energy, and level of free convection actually explain? It seems like the explanation is just looping back on itself. Tornadoes happen because air rises and air rises because there's potential energy. But does this really get us any closer to understanding the mechanics behind tornado formation? Or is this just a more technical way of saying, we don't fully know what's going on? If anything, this kind of circular reasoning shows that there's a lot we still don't understand about tornadoes, and about meteorology as a whole. So why is it that so many of us are so quick to accept certain ideas as fact? Why do we trust assumptions, especially when they haven't been rigorously tested? The answer lies in how we, as humans, process information. Once an idea becomes widely accepted, we tend to stop questioning it. We see it repeated enough times in textbooks, papers, and lectures, and we start to believe it without ever stopping to ask, but how do we really know? And over time, these assumptions become harder and harder to challenge. They get woven into the very fabric of scientific thinking, where questioning them feels like breaking a taboo. But that's exactly what science needs: people willing to ask the tough questions, challenge assumptions, and dig deeper. The greatest breakthroughs in science happen when someone dares to say, what if we've been wrong about this all along? So, next time you're faced with an explanation that feels more like an observation in disguise, take a moment to ask yourself, is this really an answer? Or is it just something that we've gotten used to hearing? Real progress in science comes not from accepting what's been passed down to us but from challenging it. And in the case of meteorology and tornadoes, it looks like there's still a lot of challenging left to do.